Hi, let's say that you were going to survey students based on the last four digits of their student ID number. Numbers can be repeated in the ID number, which means that we have replacement. We're going to choose a number for the first one, put it back in, choose again, so we can get the same number 4 times. Find the probability that for one student selected, the 4 digits contain at least one 7. Every time we select a number, we have 10 digits to choose from, that is 0 through 9. So the chance of choosing a 7 when we draw a number is 1 out of 10. But if you go down that road, you're going to find that you're not going to get the answer you're looking for. To solve this type of problem, which is the at least one problem, we need to figure out the probability of not having a 7 and then subtract that from that value from 1. Because at least 1 means that there's only one instance that we would not meet our goal, and that is if we had no 7s. Because if we had 1 7, 2 7s, 3 7s, or 4 7s, that would be at least 1. So we're really only looking for when we don't have any 7s that show up. And so the probability of getting at least one 7 is 1 minus the probability of getting no 7s. And how do we figure out the probability of getting no 7s? Well, we're looking at 4 events strung together in a row. So it's multiplication, and we're going to multiply the probability of the first one not being a 7 times the probability of the next one not being a 7, and so forth. If there's 10 digits to choose from and we say we don't want a 7 to come up, then we have 9 choices. And so that leads to this. Probability of no 7s is 9 out of 10 4 times and multiplied together. That is 9/10 to the 4th power. This one is not a 7 because of anything but 7, so I've taken out the 7 possibility. And then we take that to the 4th power and we get 0.656, rounding our probability to the 3rd digit. And then the next step is to say, well, the probability of at least one 7 is 1 minus the probability that there were no 7s, which is 0.344.